The goal that drives me here is to share the results I've reached, also sharing the quantitative tools used. Once you understand them, they will allow you to carry out the analysis completely on your own and in a very effective and efficient way. I will share some analysis in the form of slides and the code used. So we'll get our hands a bit dirty by analyzing the statistical methodologies used and the code hosted in Google Colab. If you don't know it, it's a very useful tool that you can run on your laptop without any installation. In these videos, we will try to compose a diversified ETFs portfolio by sector, investment categories such as equity, fixed income, commodities, and geographical area. It's necessary to keep all these clusters for proper diversification. Through correlation, then, we will try to answer this question, removing potential redundancies based on their similarity, and then evaluating the remaining ETFs in terms of risk return. Let's start with the data for the various ETFs I gathered from the internet. The dataset contains information on several US exchange-traded funds divided into asset classes and sectors. Most funds represent investments in equity securities of specific sectors of the economy, but there are also ETFs that invest in bonds, commodities, and international markets. As we said, the goal is to understand how to build a non-redundant portfolio and understand how these individual ETFs relate to one another. In other words, to understand how correlated they are from a statistical point of view. In this slide, we have plotted these correlation metrics, and the higher the correlation, the hotter and lighter the cells. Correlation ranges from -1 to 1, where -1 indicates a perfectly inverse relationship, while 1 is a perfect positive one. The higher this value, the more similar two particular ETFs are. So, as you can see, we have a wide correlation range that goes from a maximum of 0.99 to -0.35, which represents the relationship between bonds longer than 20 years and the financial sector. Other sectors showing negative correlation are treasury bond ETFs and equity ETFs. This could mean that in times of economic uncertainty, investors tend to move towards safer assets such as treasury bond, abandoning riskier investments like equities. Gold is another asset considered a safe haven. It shows no correlation with other equity ETFs, while it has a weak correlation with treasury bonds and with inflation-linked bonds as well. We therefore have a very dense matrix with 27 per 27 values. To make this analysis more explanatory, we can resort to hierarchical clustering. This is a statistical technique that allows us to group ETFs based on their similarity. In this way, we can avoid investing in instruments that don't add value in terms of diversification. The output of this methodology is represented by this dendrogram, where the y-axis shows the distance between clusters and the x-axis lists the various input series, the various ETFs. You can notice, for example, how short the distance is between MSCI Europe and MSCI Europeasia and Far East. The distance in this case equals 1 minus the correlation we saw earlier between the two. These two ETFs are clearly highly correlated because they practically have the same underlying exposures. The only difference is that the second also includes Japan and Australia. In general, all geographically themed ETFs are similar except emerging markets, which, as you can see, form a cluster on their own. Another interesting cluster is represented by the healthcare and consumer defensive ETFs. You can see also how gold is very distant from all other groups due to its low correlation with other assets. The next steps in the process consist of setting a distant threshold below which the various ETF clusters are aggregated. You can see them highlighted in different colors. In particular, the chosen threshold was 0.14. For each generated group being composed of similar ETFs, only the ETF with the highest return will be selected. For example, we see that in the cluster composed of technology, consumer cyclical, and the communications ETFs, the first is taken because it has the highest return at the expense of the others. The following table, after removing redundant ETFs, calculates the main performance metrics for each instrument. The table is sorted by annualized return, and we can therefore draw the insights that the technology sector has a high annual return, but also higher volatility and risk than other sectors. The high-yield ETF represents a good return to risk profile compared to other bond ETFs. However, it must be said that high yield is more correlated with the equity world, unlike treasury bonds of various durations which are inversely correlated. In the last chart, we note that return from each ETF by year. It's clear that the technology sector was the best for 3 years, including the year-to-date 2023 period. Also the energy sector. These analyses I've shared will be reproducible by you by clicking the link below. This will give you the access to the Google Colab platform with the attached code. Let's now see how you can use this code for your own purpose. So click the link in the description and you'll see the first cells are composed of libraries and functions used for the subsequent estimates. This cell loads the Excel file with all the data related to the ticker, TER, broker, and sector, which in turn are stored in Google Colab. In this cell, prices are loaded, and it's here that you can freely shorten or extend the time horizon as you wish. The cell instead simply shows the difference between price excluding dividends and the price including them. This chart represents the return from 2010 to today, considering the two different cases. Another point where you can change parameters is the following, where you can compute correlations among ETFs over a shorter time range. I, for example, use the last 4 years. Distant threshold is another parameter you can change to aggregate ETFs by considering a greater or smaller distance, and therefore greater or lesser similarity. For example, you can enter the value 0.2, which will aggregate all clusters with the correlation greater than 0.8. Finally, we have this dynamic chart that plots ETFs by volatility and analyzed return, using market capitalization as the bubble size. This ETF selection will be the basis for later videos regarding portfolio allocation management. I hope this video was useful, and write in the comments below any doubts or questions. Thank you for watching.